We are going to look at a very basic way for graphing logarithmic functions. Now, since logs are the inverses of exponentials, the graph of a log is just the reflection over the line y equals x of its corresponding exponential. So this red line here is my exponential function, b to the x, and if I were to reflect that down to here, I would get my log graph, which is the blue graph here. So the basic shape of a log graph looks like this blue line right here. Alright, example of some log graphs. This first one right here is just your very basic log of x. So this would be base 10. A couple of things that you want to notice is that we have an asymptote. We have a vertical asymptote right here at the line x equals 0. And the reason for that is because if you try to do the log base 10 of 0, that's like saying 10 to what exponent would give me 0. You cannot find anything to put in there that would give you a 0. You can get values that will get you really, really close to 0, but you would never actually get the exact value of 0. That's why we have an asymptote, because our graph is going to approach that line. Okay, this next graph right here, if you look at this, this is the graph of the log of x and then plus 3. Notice the difference between our graphs. This graph moved up, and if you were able to actually take a single point and figure out how much it moved up, it would move up 3. Notice we have the plus 3. So when my value is not attached to my x, that gives me my vertical shift. And in this case, since it was a plus 3, we got shifted up 3. Again, my asymptote is still right here at 0. Our domain for both of these also is x has to be greater than 0, because I can only have values that are bigger than 0. Reason for that is if I have the log of x and I put a negative in here, that's saying 10 raised to what power will give me a negative number. Well, there is nothing we can put in here to get us a negative number. And you might be thinking, well, what about a negative exponent? But remember, negative exponents just move you to the denominator of the fraction. So if I had put in like a negative 1 here, that would be 1/10. It's still a positive number, so we can't get a negative. Therefore, our domain for this one is x has to be greater than 0. Same thing with our original one. Our domain was x has to be greater than 0. Our asymptote is at 0. Okay, this other one. This is a graph of the log of x and then minus 4. And if you look at what happened to our graph, it was shifted down 4. Again, our number was not attached to our x, so it's our vertical shift. And since it was minus 4, it went down 4 units. Okay, here's some more examples. So this is our original again. This time, I did the log of the quantity x minus 3. So now this time, the minus 3 is actually attached to the x. Notice our graph didn't move up and down. It just moved to the right, and it moved right 3 units. So when it is attached to the x, it's our horizontal shift, just like it was when we did absolute value functions, when we did parabolas, when we did roots, when we did cubes. So when it's attached to the x, it's our horizontal shift. And again, you have to sometimes think in terms of opposites. See how this was a minus 3? Well, that actually moves us to the right 3 units. So now our asymptote changes. Our asymptote here was at 0. On this one, our asymptote is actually at 3. So my vertical asymptote would be x equals 3, and my domain for this one would be x has to be greater than 3. Because if I were to put a 3 in here, that gets me to that 0, which is where my asymptote normally is. Okay, here's one more example. This time I did the log of the quantity x plus 5. It is attached to the x, so I know that that's going to be a horizontal shift, and since it was a plus 5, I have to think in terms of the opposites, so it moved back 5. So now my asymptote is back here at 5, or at negative 5, and my domain would be x has to be greater than negative 5 for this one. But notice how they all have the same general shape. So when we're looking at the graphs of logs, the h indicates our horizontal shift, and that's the one that you have to think in terms of the opposite of. The K represents our vertical shift, and we've had H and K quite a few different times before. Our vertical asymptote is always going to be whatever our H is. So you have to be careful here. You don't do the opposite twice. So if I had x plus 7, well, I have to think of it as minusing 7 because I need to shift it to the left 7. So my asymptote would be x equals -7. My domain is always x is greater than whatever that happens to be. So for this example right here, if I had the log of that, my domain would be x is greater than -7. Your range is always going to be all real numbers. They have no restrictions when we do the graphs of the logs. Okay, if the value of b, so if our base is greater than 1, the log will go up to the right. So that's kind of the one that we've been looking at already. If b is between 0 and 1, the log goes down as it goes to the right. So it's going to go like this. So those are going to be the basic qualities of the logs that we're going to be looking at in their graphs. Now when we are graphing them, we kind of have two options. Before we get into option 1, we need to think back to these two properties we had. When we have a log base b of b, that gives us a 1 no matter what. So if my base and my number here are the same, my answer would be 1. The other one is log of base b of 1 will always give me a 0. So here's option 1 for graphing. So when we're graphing, we need to pick values of x that will give these two properties right up here. So whatever this quantity right here might be, let's say it is x plus 5, and my base is 10. Well, I need to figure out, well, what value of x will get this equal to 10. And then once we figure out what values of x to pick to get these two properties, we will use those points and then the asymptotes to sketch the graph. So that's option number 1. Here's our example. If I had log base 7 of x plus 3 minus 1 is equal to y, so for my x values, I have to get this x plus 3 equal to 7. Well, when I do that, minus 3 from both sides, I would get x equals 4. That would be one of the x values I would want to pick for my table of values. The next thing I want to do is I want to get that quantity equal to 1. So then I would do x plus 3 is equal to 1, minus the 3 off, and get -2. That would be my second x value that I would use in my table of values. Once I get my x values, I still have to plug them back in to figure out my corresponding y values, but this is one way to get good x values and good y values. Once I have those points, so I would get the x and then the y that goes with it, then I would sketch in my asymptote, which would be at -3, and use those to sketch my graph. Okay, now option 2 is dealing with shifting. So you would graph your basic log function and then do a shift of h and k units. So h would be our horizontal shift, k would be our vertical shift. Either option will result in the same graph. So if we were graphing this one again, log base 7 of x plus 3 minus 1 equals y, we would just sketch this one first. So we would get rid of all the shifts of it, and then once we get that sketched lightly, we would shift it 3 units left and then 1 unit down. So either way will work just fine. We're going to do both options. So here's our first one. Option number 1 is to get my two properties to figure out my values. Okay, so my first one, I'm going to do the log of base b of b. So that means I have to get my x plus 3 equal to 7. Well, when I do that, we already solved this before, I get x equals 4. So down here in my table of values, that is my first x value. Now to get the second property, I have to have my quantity equal to 1. So I have to take my x plus 3, set it equal to 1, and I get x is -2. Now I also want to know where my asymptote is. Well, my asymptote is always at the h value, and remember you have to think in terms of opposites, so my asymptote is x equals -3. So now I'm going to come over to my graph and I'm going to sketch in my asymptote at -3, and remember it's a dotted line because it's not actually a part of your graph, it's just a guideline we're going to use for our graph. And then I'm going to come over here to my table of values and I'm going to solve this out. So when I go to my equation and I take the log base 7 of 4 plus 3, that quantity minus 1, well, that turns into the log base 7 of 7 minus 1 is equal to y. Well, right here, this log of 7 base 7, that's equal to 1 in itself. So I end up with 1 minus 1 is equal to y, and 1 minus 1 is 0. So this time I happen to get a 0. Okay, when I plug my -2 in here, I end up with log base 7 of -2 plus 3 minus 1 equals y. Well, -2 minus 3 gives me a 1. So I end up with log base 7 of 1 minus 1 is equal to y. And this property right here, the log of any base to the 1 is 0. So I end up with 0 minus 1 is equal to y. So -1 is equal to y. So those are my two values now. So now I'm going to go ahead and plot the point for y, or for 0, not for y, and -2, -1. Now since b is greater than 1, I know my graph should be going up to the right, which it does show that here. So I'm going to use my asymptote in the fact that my graph approaches the asymptote but doesn't ever touch it, and those 2 points to sketch my graph in there. So that would be the graph of this log function using option 1. Okay, now with option 2, we're just going to graph log base 7 of x, and then we're going to do some shifting. So for my x values, I still want to get those properties I had before. So I'm going to pick my first x value to be a 7, because then I'm going to have log base 7 of 7. So when I put a 7 in there, I end up getting a 1 back. Then I'm going to do my other property. When I put a 1 in there, because I want this to be a 1, so I have log base 7 of 1, that gives me a 0. My asymptote is normally here at 0. So if I plot the point 7, 1, and remember this is the time when you just lightly plot them because we're going to be shifting them. So there I've got all my information plotted. But now I need to go back and I need to do my shifting. So I need to shift everything 3 units left. Okay, so when I'm going to shift my asymptote left first, 3 units. That puts it back here at -3. I'm going to shift that point back 3 units. And then I also need to shift down 1. Shift this back 3 units. And down 1. And then I can sketch my graph using the asymptote, because it's going to approach the asymptote but never touch it. And those other points. So these red ones are not actually part of my graph anymore. They were just guidelines to use before I did my shifting. So this would have been option 2. If you notice, we still end up getting the exact same points. This point right here is the point 4, 0, just like we had before. And this point over here is -2, -1, just like we had before. And this is the asymptote, x equals -3, just like we had before. So when you're doing the very basic graphs of these, either option will give you the exact same thing. You just have to decide which option works the best for you.